In this video, we're going to use Charles' law. Charles' law is V1 over T1, that's a divide, is equal to V2 over T2. The V still equals volume. The T equals temperature. And this has to be in Kelvin. That's important. We're going to talk about that in a second. The 1 still means start or initial, and the 2 means the ending or final. Alright. If we take a look at this question, it says the temperature in my refrigerator is about 4 degrees Celsius. If I place a balloon in my fridge that initially has a temperature of 22 Celsius and a volume of half a liter, what will be the volume of the balloon when it is fully cooled in my refrigerator? So the starting conditions and final conditions we still need to pull out. So these are our variables we're going to list. So the initial volume, the initial temperature, the final volume, and the final temperature. So it tells me my refrigerator is 4 degrees Celsius, but that's not, they're not stating if that's starting or ending yet. If I place my balloon in my fridge that initially had a temperature of, so 22.0 Celsius is my initial temperature, and it has a volume of 0.5 liters, what will be the volume, question mark, when it is fully cooled in my fridge, which they told me is 4 degrees Celsius. Now these have to be in Kelvin, and that is an easy fix. So we're going to go to our district packet. Right, so here is our district resource packet, and if you take a look right here, there we go. If I'm looking for Kelvin, I take my degree Celsius and I add 273. If I'm looking for Celsius and I'm giving Kelvin, I subtract 273. Well, these are two temperature values, so we're just going to convert between one and the other. I'm going to add 273 to both of these numbers because I need these in Kelvin. I get 295 here, 295 Kelvin, and this one should be 277 Kelvin. I usually circle these so I know which number I need to use. I don't want to use the wrong number because I'll get the wrong answer. Then I'm going to take my formula, I'm just going to rewrite it with the variables. Now I'm looking for V2, so if you're having a hard time rearranging these, always rearrange. It's easier to rearrange with the formula before you plug in the numbers. It's just easier to do it that way. So I circle this, I'm looking for V2. Since T2 is on the bottom, I'm going to make up a fraction and put T2 on top. That would be over 1, and I can cancel. And if I do it to one side, I do it to the other side. I would take the 30 seconds and rewrite this. So always start with what you're looking for on the left, and that equals, and then V1 T1 times T2. Now I can plug everything in. So V1, 0.5 liters over T1, 295 Kelvin times T2, which is 277 Kelvin. If I look here, Kelvin here is a numerator and a denominator, therefore they cancel. And I'm left with liters, which is excellent. I'm left with liters, which is excellent because I'm looking for volume. Alright, so in my calculator, I would do 0.5 divided by 295, enter, times 277. Go back to your original values for significant figures. So this one has 1, 2, and 1, therefore I can have one significant figure. And that would make the answer 0.5 liters. So the refrigerator or the freezer, nope, the refrigerator is not going to change the volume of the balloon. It is not going to be cold enough to reduce the volume. We just use Charles' law to solve for final volume.